We live in an age of, well, just incredible science, don't we? Gene editing, looking deep into space, AI.
It's really remarkable.
Yeah, but if you actually stop and think, there are these huge fundamental questions still out there. Things that maybe we just won't answer in our lifetime.
Absolutely. And, that's where the real excitement is, isn't it? The unknown.
Yeah.
So today, we're not really looking at the solved stuff.
No,
We're diving right into the deep end, the big mysteries that still have scientists scratching their heads.
Exactly. Forget easy answers. We're going exploring. We'll talk about consciousness. What even is it? And what happened before the Big Bang? That one always gets me.
Oh, yeah.
And the big one, are we alone out there? The Fermi paradox. Plus dark matter, dark energy, the invisible stuff making up most of everything.
95%.
Crazy. And why do we age? Why can't we just keep going? And then there's our own planet, the deep oceans, practically unexplored. Oh, and a bonus, dreams. What are they for? So yeah, expect some aha moments, but don't worry, we'll keep it clear. Okay, ready to jump in. Let's start with consciousness.
Okay, consciousness. It's fascinating how much we can see now. Brain activity, EEG, fMRIs, scans, looking at neural networks.
Right, we can see the lights blinking, so to speak.
Exactly. We see the hardware working. But the central puzzle is, how does all that physical stuff, neurons firing, chemicals flowing, create this subjective feeling? The feeling of being me, the awareness, the experience itself.
Yeah, it's like knowing every wire in a computer, but still having no clue how it actually runs the software, or rather, how it feels like something to be the computer running the software, that internal world.
That's it, precisely. And that gap, that's what some researchers call the hard problem of consciousness. You can find correlations. Sure, this brain pattern happens when you feel happy, that one when you see blue, but why? Why should any physical process create subjective awareness? It really challenges the simple idea that everything's just matter.
So the thing that feels closest to us, our own awareness, is still this massive scientific frontier. Wild. Okay, let's zoom out, way out, to the beginning. The Big Bang, 13.8 billion years ago. We sort of accept that, but what came before, if anything?
It's a mind bender, isn't it?
Yeah.
The issue is, our current physics, everything we use to describe the universe, it just breaks down at that initial moment. The singularity.
The singularity, right. Infinite density, infinite temperature.
Yeah, and our understanding of space and time just completely falls apart there. So the very concept of before gets incredibly tricky. Did time even exist in the way we think of it?
It's like asking what's north of the North Pole. The question itself might not make sense within the framework.
Exactly. And the ideas people float around are, well, pretty out there. Maybe there was just nothing. Or maybe our universe is just one bubble in a multiverse.
A multiverse.
Constantly butting off new universes. Or, some even half-jokingly suggest maybe it was a glitch in some giant simulation.
Okay, simulation theory is a whole other rabbit hole.
It is. But the point is, we currently have zero way to test any of this. We can't look past the Big Bang.
So it might just stay in the realm of theory forever.
It's possible. It really shows the limits of what we can know. Empirically, at least, it's quite humbling.
Truly humbling. Okay, changing gears again. A question people have asked forever. Are we alone? Look up at the sky. I mean, the numbers are staggering.
Oh, absolutely. Hundreds of billions of galaxies.
Each with billions, maybe trillions of stars and planets around, most of them, we think.
The odds seem overwhelming, right? Statistically, it feels like there should be life out there, lots of it.
But then silence. Nothing.
Yeah.
No signals, no probes, no evidence of anyone else. And that's the Fermi paradox, isn't it? This huge contradiction.
That's the core of it. Where is everybody? Given the age of the universe and the sheer number of potential homes for life, why haven't we heard anything? It's genuinely puzzling.
It feels a bit lonely, actually. So, what are the leading ideas? How do scientists try to explain this silence?
Well, one idea is maybe we're just early, really early. Maybe complex, intelligent life takes a very, very long time to develop, and we're among the first civilizations to get to this point.
Okay, that's a hopeful word.
Another possibility, a bit darker, is the great filter idea.
The great filter.
Yeah, the theory that there's some incredibly difficult, maybe almost impossible step in the development of life or civilization that stops most potential life from becoming spacefaring.
And the scary part is that filter behind us, meaning we passed some incredibly rare test. Or is it still ahead of us, like climate change or nuclear war or something we haven't even thought of?
Exactly. It could mean that civilizations tend to, well, self-destruct before they get advanced enough to be easily detectable across interstellar space.
Gives you pause, definitely.
Oh, yeah.
Right, let's move to another cosmic puzzle. The stuff we can see, stars, planets, us, that's only about 5% of the universe.
Just 5%. It's astonishing when you think about it.
So what's the other 95%, this invisible majority?
That's arguably the biggest mystery in cosmology right now. We know it's there because we see its effects, but we don't know what it is. We've basically given labels to our ignorance. Dark matter and dark energy.
Okay, so break those down. Dark matter first.
Right. Dark matter doesn't seem to interact with light at all, hence dark, but it definitely has gravity. We see galaxies spinning way too fast for the amount of visible matter they contain. Something extra, something invisible, must be providing the gravitational pull.
Like an invisible cosmic glue holding things together.
That's a decent way to put it. We also see its effects in gravitational lensing, where light from distant objects gets bent as it passes by massive, unseen clumps of something. That's dark matter.
Okay, so that's one part of the 95%. What about dark energy?
Dark energy is even stranger, maybe? It seems to be some kind of energy inherent in space itself, and it's causing the expansion of the universe to accelerate. Galaxies aren't just moving apart, they're moving apart faster and faster over time.
Pushing everything apart.
Wow. Yeah, it acts like a sort of anti-gravity on cosmic scales.
Yeah.
The leading idea is maybe it's related to the cosmological constant Einstein proposed, like an energy density of empty space itself.
But again, dark just means we don't really know what it is. We see the effect, but not the cause.
Precisely. We haven't directly detected a dark matter particle, despite huge experiments trying. And dark energy is purely inferred from its effect on cosmic expansion. Figuring what these actually are would be revolutionary.
Mind-boggling stuff. Okay, well, let's bring it back home, back to us biologically. Why do we age and die? It feels inevitable, but our cells repair themselves, right? DNA gets fixed.
That's a great point. We have all these amazing maintenance and repair mechanisms built into our cells. And when you look at the natural world, it gets even more curious.
How so?
Well, there are species out there that show negligible senescence. Basically, they don't seem to age in the way we do. Think about certain jellyfish or hydras. Under the right conditions, they seem almost biologically immortal.
Immortal jellyfish.
Right.
And things like salamanders regrowing limbs.
Exactly. So the biological machinery for incredible self-maintenance and regeneration exists in nature. It raises the question, why don't we have that indefinitely? Why do our systems eventually break down?
So what's the thinking? Why do we age?
Oh, it's super complex. Probably a mix of things. Damage accumulating in our cells over time that repair mechanisms can't keep up with. The shortening of telomeres, those protective caps on our chromosomes.
Telomeres, okay.
Genetics plays a big role too. Certain genes influence lifespan. If we can really crack the code of aging, understand all those interconnected processes, well, the implications for extending healthy lifespan are obviously enormous. Immortality is probably a stretch, but longer, healthier lives, maybe.
It connects back to those fundamental questions about life itself. Okay, another big unknown, maybe closer than we think. The deep ocean. We've mapped Mars better than our own seabed.
It's true, and kind of shocking, isn't it? Less than 5% of the ocean floor has been explored in detail.
Less than 5%.
Think about the conditions down there. Crushing pressure, total darkness, weird chemistry around hydrothermal vents. It's an extreme environment.
So what could be hiding down there?
Honestly, almost anything. Entirely new ecosystems, bizarre life forms adapted in ways we can't even imagine yet. Maybe even new branches on the tree of life, things that evolve completely separately. It's like an undiscovered planet right here on Earth.
An alien world in our backyard. You could find creatures that look like they're straight out of science fiction.
Absolutely. And exploring it isn't just about finding cool new creatures, though that's part of it. You could tell us about the limits of life, how life might arise in extreme conditions, maybe even give clues about life on other planets or moons with subsurface oceans.
So much potential discovery. Wow. Okay, last one. Our bonus mystery. Something we all do every night. Dreaming.
Dreams, yes.
This bizarre, vivid, often totally illogical stuff happens in our heads where we sleep. What is going on? Why do we do it?
It's a classic question, right? And we still don't have a single definitive answer. There are several strong theories, though. One popular idea is that dreaming is crucial for memory consolidation.
Sorting the day's information, like filing things away.
Sort of, yeah.
Yeah.
Processing experiences, integrating new knowledge with old, maybe discarding unimportant stuff. It's like the brain's offline maintenance period.
Okay, that makes some sense. It doesn't feel totally random sometimes.
Then there are theories that dreams are like a simulator. Maybe we practice dealing with threats or work through emotional conflicts in a safe space. Some Freudian or Jungian ideas suggest dreams tap into our subconscious desires or archetypes.
Right, deeper psychological meanings.
And some even wonder if it's, a different state of consciousness entirely.
Yeah.
Maybe offering glimpses beyond our normal waking reality, though that's more speculative.
But the bottom line is, despite all the theories, we don't actually know for sure why we dream.
That's pretty much it. Its true purpose, or maybe multiple purposes, is still one of the big unknowns in neuroscience. It's funny how something so common can remain so mysterious.
It really is. And that kind of sums up everything we've talked about, doesn't it? Despite all our progress, these huge fundamental mysteries persist.
Mm-hmm. And it drives home that point. The more we learn, the more we realize how much we don't know. The boundaries of our knowledge just keep expanding, revealing an even vaster unknown.
But that's not discouraging, is it? It's
Yeah.
kind of exciting. It's what keeps science moving forward.
Exactly. And it's what keeps us curious. And really, you listening right now, by just thinking about these things, by asking questions, you're part of that ongoing quest for understanding.
So as you go about your day, maybe mull over some of this. Think about the fact you're a conscious being trying to figure out consciousness, or that 95% of reality is invisible to us right now. Or maybe tonight, just before you fall asleep, wonder about the weird journey your mind is about to take. Because these big questions, these unknowns, they remind us the adventure of discovery is nowhere near finished. There are still so many secrets out there.